if you think pointers in programming are confusing, or if you don't have a very good understanding and you don't know exactly how they work, why we use them, or the best ways that we use pointers, I'm making this video in hopes that you have a better understanding and in hopes that you can actually use them and not be confused, because pointers are very confusing at the start and we don't want to be confused basically. So before we actually dive into some code, let me just get our bad boy Krita here so we can draw. So basically, what is a pointer, right? So a pointer is, let me just put it here, yeah, okay. A pointer is a data type, meaning it's not actually something that we can touch. So just like an int, just like a char, just like a long, just like a boolean, pointers are a data type, and in the name they point to something. What they point to are memory, address. So basically, let's say that this is our memory, okay, and our memory have a bunch of stuff. So for example, here we have a variable, here we have a string that is also a variable, but let's say this is an int variable. Right here we have some memory allocated to a string we just created using malloc. Right here we have other stuff. So this is our memory. What a pointer do is that it will point us to a certain address on the memory, because these variables right here that are stored in memory, they're not just floating around and just chilling. They are actually in fixed address on our memory. So let's say this address is the address 0 times, I don't know, 5A6 7, for example. This is a memory address. So what this pointer will do is that it will search for the address of the variable we give it to it, and then it will assign, in this case, this address, and we can perform operations such as printing the address, or printing the value inside the address, or changing the value that is in the address. So let's just do this. For example, we have int number equals to 5. So basically, this variable right here, this number, is somewhere in the memory, and in this address in the memory we have NBR, which holds the value of an integer equals to 5. Now if we do, for example, int and then pointer ptr equals to NB, so right here we have a lot of stuff going on. It's easier to visualize in code, but basically this pointer right here is going to be pointing to the same address as NBR, and then we can use this bad boy here to perform operations. Now let's get rid of this drawing. Let's put it here. Okay, so I have a bunch of libraries, don't worry, it's just because I like having them all here. So let's say we have int number is equals to 5. Well, if we printf number equals to percentage d slash n, and we put number, here, yeah. So we compile and we run, we know that number is equals to 5. Cool. Now we say that int pointer is equals to number. Now a lot of stuff is going on here. First we have this symbol right here, and we have this symbol right here. So going back to our drawing, let's explain this a bit better. Let's erase all of this. Okay, now let's come back to our drawing. table here. Okay, so basically what this symbol right here does is that it is dereferencing the value, so dereferencing the pointer to the address. This bad boy takes the address of number, yeah. So what is dereferencing and why do we need the address? So basically, if we were to print pointer, address of pointer, and the dereference of pointer, we'll have three different results, because this is the address that the variable pointer is stored, not the variable number which it is pointing to. If we just print pointer, this will print the variable. This, yeah, so basically this var pointer right here will be dealing with the address of pointer, and this pointer here will hold the value of the address of the variable number. In this case number, because we have number here. Now this we are dereferencing, meaning we are accessing the address of the variable. So let's put it like an analogy so it's easier to understand. So this is us. Okay, this is us. And we want to visit our friend variable x. Because our friend has a book, and on this book is a value that we need to use. But we don't know where our friend lives. So we go to this bad boy called pointer. So we go to pointer and say, hey, what's up? I need the address of variable x because I want to use the value that it is stored inside it. And then the pointer says, oh, alright, the variable x lives on this address of the memory. I don't know, like 0053551, that, etc. And then say, oh, thank you, and then we can directly go to our friend variable x and say, oh, okay, so give me what is on your book, and then this is the value. So us using the dereference will be equals to 5 if we print it, which I'm gonna show later. But simply us, well, we are basically let's say this pointer is us actually because it's easier to understand. Us is just holding the value of variable x, holding the address of variable x, which is 0 times 5, 3, 5, 1, etc. But the address of our pointer is different than the address of variable x. So getting rid of our drawing again, let's put it here. Okay, getting rid of our table. So if we were to come here and then we do printf pointer equals to percentage d, and then we dereference the pointer. So if I learn how to write printf, so here in this case we are dereferencing pointer. So we compile it again, and then you know that the reference of pointer is equals to 5. However, if we just print, for example, the address of number is equals to percentage p, in this case, /n, and then we put the address of number, and we printf the address pointer is pointing is percentage p again because it stands for pointer. Then we just simply put ptr. Well, in this case, let's just do like this. Yeah. So in this case, as you can see, the address of number is 07FF3C34C4FC, just like the address that pointer is pointing, which is 0 times 7FFF3C34C4FC. So here we can clearly see that when we are dereferencing a pointer, we are going to the value that it is pointing to. So in this case, we can clearly see that the value of ptr is the value that is stored in NBR. So because we cannot simply do int ptr equals NBR. This is incorrect. Why? Because we have an incompatible integer to pointer conversion, so I have an int pointer to an expression type int. We would need something like this, but this won't work. This is why we need to dereference it. But if you want to see something cool, the actual address of pointer is the %p/n, and we put the address of pointer. So we compile and we run the program. Well, the address of pointer, not the address pointer is pointing to, but the address of pointer itself, is 0 times 7FFD4D3A3F00. So with this, we can basically get a few grasp on how to do with it. However, I can even do int pointer second is equals to the address of pointer. So in this case, we could do like this. Let's just do something like this to separate everything. Here and here. So second pointer is equals to percentage, let's say percentage d/n, then we dereferencing sec. So we compile, we run. So as you can see, our pointer is, so we have a pointer to a pointer called sec, and when we dereference sec, we get 5. But what happens if we just put one pointer here? Well, we can't. Why? Because the format specifies type int, but the argument has type int pointer. Basically, if we just dereference once, it is still a pointer. So we would have to do something like this. And now we compile. But the second pointer now is not giving us the value. It's just giving us the address of, the address of the pointer that pointer is pointing to. So this gives us the value of NBR, and this gives us, now we do %d, gives us the address, gives us the value that is stored on the address that NBR is. And we also can have, of course, int pointer sec. This will be third. That will be the address of sec. And then again, if we were to do like this, so this would be the third pointer, and then put another pointer here, and we do third. If we were to compile and if we were to run, we would have the same thing. So here we would keep dereferencing stuff, but something very cool about it is that we can use pointers to change the value stored on the variable that we are pointing to. So we do int nvr equals to 5, we do int pointer is equals to nvr. So we printf %d num is equals to, and then percent and then slash n and put number. Well, of course, if we compile news variable ptr and I compile, we know that num is equals to 5. Cool. But if we come here and say that ptr, so the address stored on ptr is equals to 7, and we do it like this, num2, well, then we know that num2 is equals to 7, so we didn't change the number in any way, we just changed the value that is on the address of number. So of course we can do something like pointer equals to this big ass number here, and then let's do first number is equals to, and second number is equals to. So we changed the value of a variable without touching the variable, but only changing touching the address of certain variable. And we don't only need to use it for ints, we can also do it with different data types such as chars. So let me drink some water. Cool. So we have char str equals hello, and now we have a char double pointer because we are pointing to a pointer. When we have a char double pointer, we call it a matrix, but in this case let's just use it as a regular pointer. So pointer is equals to the address of str. Now if we were to print again the value of pointer, it would be %s/n, and then we dereference and do ptr. And again, I don't know how to write printf. Yeah, nice. But oh wait, it specifies type char, but the argument has type char, so it would need to be a %c. Now why is it? Because differently from ints, our first pointer here would be basically just str. But since we are dereferencing this, we are dereferencing str, so we are accessing the first char of str, because you see the value is consecutive addresses of hello. So just to have a better understanding, think of it like this. I have our memory here, and a char pointer will point to consecutive memory addresses, so 0 times something 1, something 2, something like 0 something 3, 0 something 4, and consecutively. And each character, because a string is basically a string is an array of characters, each character will be on the next address, so they are neighbors, and the pointer points to the first one when we dereference it. So this is a string in C. So in this case, we put a %c because we are dereferencing 2 times, so we are accessing this and the first letter here. So if we compile it, value of pointer is equals to h. But now, if I do this and compile again, now the value of pointer is equals to hello. And if we put just pointer itself, it will show us the address of str. So printf. So the address of str is equals to percentage p slash n, and then I put the address of str. And now I did this, compile, and as you can see, the address are the same. I hope you can see. Put it, make it bigger. So 0 times 7 ffc, 0 times ffc. But if I do like this, we have something interesting. Let's compile. Now the address changed. Why? Because this address here is not the address that pointer is pointing to. Because if we were to do like this, this address right here is not the address of str, but it is the address of the first letter h. Because if we were to do like this and like this, we can see that they are the same. So basically, pointer in this case is pointing to the address of h, so where h is stored. And if we were to do like this, no, this wouldn't work, yeah, but just for you to have a grasp. So we know that this is F004. We compile this and use the variable. We compile, we do it out. Now we can see that the address of H is F004, and this is 560B540EA005. Here it doesn't look like they're pointing, like they're consecutively, they're neighbors, but they are basically. They just don't, the address is not the way we think it is. It isn't like this. So we put the second, and now it is the last digit I know is fixed. It's fixed. So like 4, 5, 6. The third will be 7, but the rest of the address is different. Yeah, that's it. We can have pointers to pointers, and we can change things through pointers. Just like, for example, let's just, so str is equals to percentage s, and then we put str. Cool. Now we say that ptr is equals to what's up, and then we printf this again. So first and second. So again, we didn't touch str nowhere, but we can change the value of str using a pointer to it. Now if I wanted to do like this, I would need to do something like this, and now this would be wello. So we compile. Oh, actually we have segfault. Yeah, let's just see what this bad boy is telling us. So invalid permissions for mapped object. Oh yeah, okay, yeah, that makes sense actually. So yeah, these are pointers and how we deal with it. So print that pointer /n, compile and run. Yeah, cool. So basically, I think this video is kind of long. Yeah, it's kind of long, but anyway, these are pointers. I hope it is very clear and very understandable how they work, why they work, how we can use them to do stuff. And yeah, bye.